Hi guys, it's Mrs. Tucker. We're going to start a little project here. It's a activity that helps explain functions and how they work, and you guys are very familiar with this. It's an algebra-based project, and it's going to get you ready for high school. Okay, so let's get started. This is called Valentine's Day Ideas, and this is activity 1, so it's the first part. The school's drill team has contacted several flower distributors and has narrowed the choice to 2 companies. Option 1, Roses Are Red has offered to sell its roses for fixed down payment of $20 and an additional charge of 75 cents per stem. That means per rose. Option 2, Flower Power has offered to sell its roses for a fixed down payment of $60 and an additional charge of 50 cents per stem. Which one is the more economical offer? So let's switch over to this page. This page says, Activity 2, using tables to find the more economical offer. From the description of the 2 offers, complete the chart to find an algebraic rule that will determine the cost of n number of roses. Okay, so we've got this table. You're going to start off with number of roses. You're going to use 10 roses. This is your process column. This is your cost at Roses Are Red. Here's your process column for Flower Power and the final cost for 10 roses at Flower Power. Okay, I'm going to get you guys started, and then you guys are on your own to finish filling this part out. Okay? Now, Roses Are Red, what was that offer? Roses Are Red is a fixed down payment of $20 and 75 cents per stem. So, in your process column, it was a fixed down payment of $20 plus, what did it say, 75 cents per stem? 75 cents per stem for 10 flowers. 75 cents per flower times 10 flowers. Well, if you take 10 and multiply by 0.75, you get $7.50. If you add that onto the 20, you get $27.50. Okay? Let's do it for 20 roses. They have a fixed down payment of $20, and then it's 75 cents per rose times 20 roses. Okay? Well, if it was $7.50 for 10, it's going to be $15 for the 20 roses. $15 added onto this is $35. Okay? So you guys are going to finish doing this column here on your own. I've got it started for you. I know you know how to finish this out. If you guys want to use a calculator on this, I will let you do that. Okay? Let's look at the process column for Flower Power. Let me go back and see what they said. Flower Power said they're going to charge $60 down payment, but 50 cents per flower. So let's do that. $60 down payment for Flower Power, but they're only going to charge 50 cents per flower. And we're going to buy 10 flowers here. So if you take 50 cents and multiply by 10, you've got $5. $5 added onto 60 is $65. Okay? What if you buy 20 flowers? Well, there's a $60 down payment, plus you still have to pay 50 cents for every flower, and that's 20 flowers. We're going to buy 20 flowers this time. So if 50 cents times 10 is $5, then 50 cents times 20 is $10. You add that on to 60, you've got $70. Okay? I want you guys to finish filling out this part of the table. So when you're done, you should have this all filled out. I want you to pause the video here. Let the kids finish filling this out. Okay, you guys should have had time now to finish filling out all 4 of these columns. When you got done filling them out, did your numbers look like mine? Let me see if I can scroll this down a little bit. Did your numbers look like mine? Take a moment. We might have to pause the video here. See if you got what I got. Okay, so now we have to figure out what the expression is that goes in each one of these boxes. Okay, we're looking for an expression, and this time instead of calling the number of roses 10, 20, 30, 1,000, we're just going to call it n. All right, look in your process column. What numbers never change? It looks like that 20 never changes. The addition sign never changes. And the 0.75 or 75 cents per stem never changes. So down in our box down here, in this box right here, we're going to write 20 plus 0.75. What are all of these numbers here that are always changing? Yeah, this is your variable here. That is this column here, and we're going to represent the number of roses by the letter what? Yeah, n. So that's what goes here. So our expression for the cost for any number of roses is going to be 20 plus 0.75 n, where n represents the number of roses that you purchase. Okay, well, let's do the same thing over here for flower power. What never changes? Yeah, the $60 up front never changes. The addition sign never changes, and the 50 cents per stem never changes. What are these numbers that are always changing here? Yeah, that's your number of roses. So down here in our process, we can write that the cost at Flower Power is 60 plus 50 cents for every flower times what? Yeah, times the number of flowers. So does your expressions for the cost for both look like mine? Okay, great. Let's move on. Let's go to the bottom of this page. At the bottom of the page, there's 2 questions. It says write a sentence and a function rule for the cost of the roses from Roses Are Red. Okay? They charge a down payment oops, that's in the way. Down payment of $20 plus what? 75 cents per stem. They also want you to write the function rule. So we're going to say cost equals what? 20 plus what comes next? All right, good. I want you guys to do number 2 on your own. Do the same thing, but I want you to do it for Flower Power.